Let's start with a pretty wild question.
And I'm not talking about simple little web apps. I mean the heavy-duty stuff. Complex video editors, high-end 3D games, maybe even entire operating systems, all running instantly, right in this tab, with no downloads. That's the revolutionary idea we're digging into.
But to really wrap our heads around how that's even possible, we have to ask the big question. What is WebAssembly, anyway?
For decades, the web had its own little club. HTML for structure, CSS for style, and JavaScript for, making things happen. Well, WebAssembly, or WASM for short, is the new member of that club. But here's the twist. It's not for humans to write. It's a super efficient, low-level format that acts as a universal bullseye, a target that lets code from other languages like C++ or Rust run right inside the browser. And this isn't some brand new experimental tech that might fizzle out. WASM has been on an absolute tear since it was announced back in 2015 by all the big players. We're talking Google, Apple, Microsoft, Mozilla. By 2017, boom, it was in every major browser. And by 2019, it became an official web standard. This thing is mature, it's established, and it's moving incredibly fast.
But here's the thing. The real promise here isn't just about making websites a little bit snappier. It's about letting entirely new kinds of applications live on the web for the very first time.
I mean, take a look at this. This right here was considered impossible just a few years ago. Adobe managed to bring a version of Photoshop, with its millions and millions of lines of C++ code, straight to the web. They didn't have to rewrite it all in JavaScript. Nope, they just compiled it to WebAssembly.
And the performance you can get is just stunning. What you're looking at is the entire game engine for Doom 3, a super graphically intensive 3D game, just running smoothly inside a browser tab. This is the kind of heavy lifting WASM makes possible, executing really complex code at speeds that get incredibly close to native.
But okay, running desktop apps in a browser, that's just the beginning. What if you could take that same portable, high-performance engine and run it completely outside the browser? That's where the real revolution is happening right now, on the server. And this is all possible because of something called WASI, the WebAssembly System Interface. The easiest way to think about it is like this. Inside a browser, WebAssembly is locked up tight in a secure sandbox. WASI provides a standard set of keys, which lets that code safely talk to things outside the sandbox, like your file system, the system clock, and network connections. And the implications of this are just staggering. Get this, Solomon Heiss, the co-founder of Docker, actually said that if WASM and WASI had been around back in 2008, they wouldn't have even needed to create Docker. Think about that. He's saying this combo could be a fundamentally new way to build and run software, something that could even challenge the dominance of containers.
But of course, like any powerful new technology, WASM isn't perfect. It's got its own set of challenges and, yeah, some growing pains. So it's really important we get a balanced view here.
Because despite all the excitement, it's not a magic fix for everything. There are some really critical trade-offs, especially in security and performance, that we have to talk about. Okay, let's start with security. The WASM sandbox itself is incredibly strong, but research has pointed out a really important detail. When you compile code from older, memory-unsafe languages like C++, you can bring old vulnerabilities along for the ride. And what's worse, some WASM environments don't have the modern defenses that our operating systems do. Things like stack canaries, which are like digital tripwires. And that means some old-school attacks can suddenly work again.
And then there's the performance side of things. Remember when I said near native speed? Well, that comes with a bit of an asterisk.
A really big study found that, on average, WASM applications ran about 45 to 55% slower than their native versions. Now, to be fair, that's still a massive speed-up over traditional JavaScript for many things, but it proves WASM isn't some free ticket to perfect native speed in every single case. There's still a gap there. So, how is the WebAssembly community tackling these challenges? Well, they're building the future, with two key developments that are pretty much changing everything.
Yeah, there are two major updates that are absolutely critical to know about. WASM GC, which stands for garbage collection, and something called the component model.
Early on, WASM was perfect for languages like Rust and C++, where programmers manage all the memory by hand. But most of the world's code is in languages like Java or C# that use a garbage collector to handle memory automatically. WASM GC builds that capability right into WebAssembly itself, which makes it a fantastic target for this huge ecosystem of languages for the very first time. This is a total game changer.
It means millions of Java and Kotlin developers can now bring their apps and libraries to the web and beyond without having to learn a completely new language. It just dramatically expands the number of people who can build for WASM.
And that leads us to the second big thing, the component model. If WASM GC is about bringing more languages to the party, the component model is about making sure they can all talk to each other. It's a standard for building WASM modules that are kind of like language-agnostic Lego bricks. You could have one piece written in Rust, another in Python, and a third in Go, and they can all just click together and work seamlessly in the same app. This is the key to building really big, complex systems with WASM.
So we end up back at that big question. With a secure sandbox, with broad language support thanks to WASM GC, and with this true interoperability from the component model, WebAssembly is becoming so much more than a web technology. It's becoming a universal runtime. It started on the web, sure, but its ambition now is way bigger, to be a portable, secure, and efficient way to run any code anywhere. And that is a future that is definitely worth watching.